Okay, so this is going to be the fourth video of our exam review. A couple of apologies. I'm shooting this at home. And so a couple of changes in auditory performance. I'm using a headset mic instead of an omnidirectional. And also, dopey me, I left my TI-84 at the school. So, some of these we're just going to have to solve the old-fashioned way using completing the square, which is a skill you learned in the last unit. Actually, you've learned it several times. But first, let's get to the vocab. When quadratic equations cannot be factored, the quadratic formula can be used to solve for x. But before we can use the quadratic formula, quadratic equations must be put into standard form, and the blank is asking you, okay, what is standard form? So that's going to be actually is general form, and that's going to be ax squared plus bx plus c is equal to 0, or you might have it as equal to y. And again, a, b, c are going to be known real numbers. I need a new pen. Hang on. Well, that's irksome. Alright, let's go with blue. Okay. So, in this equation, a, b, and c are constant numbers, specifically real. Those numbers have been identified that can be plugged into a quadratic formula to solve for x. And so the next part of the review is asking, hi, do you remember what the quadratic formula is? And that, of course, is that x is equal to negative b plus or minus the square root of b squared minus 4ac, and the whole thing is being divided by 2a. Of course, there are two solutions, one where you add the discriminant and the other where you subtract the square root of the discriminant. Sorry, the square root of the discriminant. One where you add, one where you subtract. Okay. The solutions we get for x are called roots. Graphically, they are the point where the parabola intersects the x-axis in the quadratic formula. The expression underneath the square root sign is called the discriminant. That's indicated by a capital D, and that is equal to the b squared minus 4ac. Discriminant tells us how many roots the equation has and the nature of those roots. If the discriminant is 0, then there is one real solution. Literally a double root. Because there is only one solution, this means the vertex of the parabola lies somewhere on the x-axis. If the discriminant is greater than 0, then there are two real solutions. The parabola will intersect the axis twice. These points of intersection are also known as zeros. Again, with a quadratic, it's a second-degree polynomial, and so the number of solutions matches the degree of the polynomials. Okay, on to the next one. If the discriminant is less than 0, then you are taking the square root of a negative number, and so then there are two imaginary solutions, or rather two complex solutions. Well, complex doesn't get it. Two imaginary roots. Solutions. Literally, the solution set becomes two complex conjugates, and graphically, you do not see a point of intersection at all. And so if I could sketch this for you, if your discriminant is equal to 0, it would look something like this, where it hits the axis and bounces up. If the discriminant was greater than 0, it would look something like this, where it hits the axis in two places. And then if the discriminant is less than 0, then it would look something like this, where it doesn't hit the x-axis at all. And so that's your basic idea. So remember these properties of a discriminant, because you never know. We might ask a question that simple, not asking you to find a real root, but asking you to describe roots based on the scenario. Okay, so for the next part, it is asking you to find the vertex of a parabola. Well, the easy way would just be to graph the stupid thing by using a calculator, which of course is always at your disposal. But in this case, I'm going to demonstrate completing the square. And so to complete the square, your first step was to cancel the constant. Of course, the constant is 5. So I have y plus 5 is now equal to 2x squared plus 8x. Then I have y plus 5 is equal to 2 times x squared plus 4x. Now, I'm going to complete the square by adding a constant, which is the square of this divided by 2. Okay, well, 4 divided by 2 is 2, so I'm going to add 2 squared, but that 2 squared is inside the parentheses. And so 2 squared is 4 times 2 is 8. So really what I just did was I just added 8. So now I've got y plus 13 is equal to 2 times x plus 2 quantity squared. And then to finish it off, I remember that this is actually the same as y is equal to 2 times x plus 2 quantity squared minus 13. And so my vertex is going to be, because insiders lie, -2, -13. Okay? That one was a little bit tricky, but again, completing the squares technique that you learned in conics comes in handy. This one, again, same basic idea. We're going to say, all right, y minus 7, because we subtracted 7 from both sides, is equal to x squared minus 3x. Okay. Now, to complete the square, I'm going to take half of this and then square it. So I'm going to add -3 over 2 quantity squared. Well, that's plus -3 over 2 quantity squared. Now, this then becomes x minus 3 over 2 quantity squared. Because the square is now complete, we can compress it. 7 plus 9 over 4. So that's going to be y is equal to, or y plus 9 over 4 minus 7. Well, 7 is 28 over 4. And so 28 minus 9, it's going to be a negative number. We'll lateral it around in just a sec. So that would be -19 over 4 is equal to x minus 3 over 2 quantity squared. And then we move it back. And we say, okay, y is equal to x minus 3 over 2 quantity squared plus 19 over 4. Again, this is going to be a little bit on the ugly decimal side, but we'll just kind of deal with it. Okay. Next one, asking you to find the zeros of the equation. And so the easy way to do it is you can set this equal to 0. So we have x squared minus 7x plus 12 is equal to 0. You could solve the zeros by completing the squares also. But in this case, we look at our factors of 12, and we look for the factors of 12 that add up to -7. We know they're both going to be negative because they have the same sign. So we look at x and x. We know it's going to be minus and minus. And the factors of 12 that add up to 7 are going to be 3 and 4. Now we've got this in what's called a factored form. We recognize that insiders lie. And so we're like, okay, the solution set for x is the set of x such that x is positive 3 and positive 4, because insiders lie, and those two are inside the parentheses. Okay, next one, a little bit more fun. 2x squared plus 2x minus 12 is equal to 0. One of the most absolutely beautiful things about 0 is I can divide 0 by 2 and change nothing about my right side. So that's really cool. So I'm going to divide each of these terms by 2. And so 2x squared, I'm just going to say, okay, divide by 2, divide by 2, divide by 2, divide by 2. Okay, 0 is still 0. This is now -6. This is now x, and then this is x squared. Okay, looking for the factors of -6 that have a difference of 1. So we have x plus something and x minus something. And, well, the factors of 6 are 2 and 3. They do have a difference of 1. And we know, because this is positive, the 3 is going to be the positive one, 2 is going to be the negative one. Once again, insider's lie. So we have x is -3 and positive 2. So that was fun. Again, at this point, being able to factor a polynomial should be second nature to you. If not, again, you will have access to the calculator. And so if you were graphing this, you would actually see a graph that looks something like this. And so here's 1, 2, 3, and here's 4. And so it would kind of short-shot shoot its way up. This one, they'd be a little bit farther apart, but you look for those 2 points of intersection. This one, you're looking for the maximum value of the equation. Or in this case, the minimum. Well, we know this parabola is going up because the leading coefficient is positive, and it's already in vertex form. So insiders lie, so we have a point of 2, 5. That is our vertex, and that is the lowest point. So in this case, it's high. Do you know that this is vertex form? You don't even have to graph this thing. I mean, you could if you wanted to, but why spend the time? You're going to have it's a 40-question exam. You have 40 questions in 90 minutes. You have basically a little bit less than 2 minutes of problem to read, compute, come up with a solution, and bubble. And I know some of you are slow bubblers. By the way, if you wait to the end to bubble, I am not going to be happy with you, and when time is time, you're done. Okay, so this one, 2, 5 is the minimum, and that's it. This one, not my idea of a good time. If I were you, I would graph this on a calculator. Since we've already been at this one for 12 minutes, we know it's a max. We know it's a max value because basically we know that this is a downward parabola. Also, do not be surprised if finding the vertex is the easy part, but basically one solution will be the vertex is a max, and the other solution is going to be that the vertex is a min. So there's an element of, hi, do you know what you're looking at? Okay. So I'm just going to, negative b over 2a. Yeah, in this case, the maximum value is going to be a really hideous decimal, and I do not feel like finding that right now. Sorry. I'll have to show you on a calculator in class if you're really, really anxious. But again, graph it. You can actually find the point of intersection. Nothing on the final is going to be too ugly of a decimal. All right. Practice problems. This is high. Can you read a word problem and understand what it's saying? Okay. Base of a triangle is 4 centimeters shorter than its height. Okay. So we're going to say that base is 4 centimeters shorter than 3 times its height. So 3 times its height minus 4 centimeters. So there's our equation for our base. Area of a triangle is 192 square centimeters. What they're assuming is that you remember that the area of a triangle is equal to 1/2 of the base times the height. In this case, hi, do you remember that this is 1/2 of 3h minus 4 times h? Okay. Again, you have that is now equal to 1/2 of 3h squared minus 4h. And remember, they said that the area of the triangle is 192. Okay, at this point, hi, can you turn it into a standard form quadratic? You can. Just to make my life easier, I would actually cancel 1/2 by multiplying by 2. And so if I multiply both of these by 2, I get 3h squared minus 4h equals 384. And then I would say, okay, 3h squared minus 4h, minus 384 is equal to 0. Now, at that point, I would try graphing this on a calculator and finding where it crosses the axis. One of the solutions will be positive, the other one will be negative. The alternative is to use the quadratic formula, both of which will provide you with an adequate solution. Obviously, a height of a triangle cannot be negative, at least not in this universe. Let me rephrase. At least not in Algebra 2. Calculus, you do run into negative areas, which are really fun to play with. But anyway, okay. Solve using quadratic formula. Okay, so we say, hi, a is equal to 1, because this is actually 1x squared. B is equal to 6. C is equal to 10. Notice I am not using the variables. I am only interested in the coefficients. If you try using a variable to solve for itself, you're a lunatic. Very simple. So you have x is equal to negative b plus or minus the square root of b squared minus 4ac, and the whole thing is over 2a. I'm writing that formula out for you, not because I need to remember it. But best way to do it is you actually plug the formula in dry, as I call it. So you have the negative sign, you're going to put a parenthetic there, plus or minus the square root of b squared minus 4ac. Those parentheses are very important. If you don't put them, you'll drop a negative sign and you will totally screw it up. 2a. Okay, so a is 1, b is 6, and c is 10. Now, in this case, I'm going to need a little bit of paper. Because it's not all going to fit in the same place. Okay, so we're going to simplify that out. By the way, your test will come with scratch paper and grid paper and formula charts. I saw to that. So you have negative 6 because you don't have much to distribute there. You've got plus minus the square root of 36 minus 40. Well, that tells me that my solutions are about to be imaginary, but that's okay. And the whole thing's over 2. Well, we've got negative 6 plus or minus the square root of negative 4 over 2. Well, the square root of 4 is 2, and the square root of negative 4 is 2i. So you have negative 6 plus or minus 2i, and the whole thing's being divided by 2. Now, notice that everything is divisible by 2. So we actually think of this as negative 6 over 2 plus or minus 2i over 2. So then that becomes, oops, and I'm off the page. Here we go. Negative 3 plus or minus I, and those are your two imaginary solutions. So that was fun. Okay. And we're going to stop here because we're on to Unit 6.